Hey, well, I've been feeling really tired in Miss Ramos's class. Do you know anything that could help me out?
Well, I just learned about this pharmaceutical called modafinil, which might help. Let me tell you about it.
Okay, yeah. Yeah, so modafinil. So we're gonna talk about its purpose and use, its chemical structure, whether it's chiral or racemic, its enantiomers, benefits and side effects, background and commercialization, and then some interesting facts. So Abel, please tell me about it.
So, the purpose of modafinil is it's a wakefulness promoting medication, and it's been used to treat excessive daytime sleepiness. Its medical uses include a treatment for narcolepsy, obstructive sleep apnea, but it also has some off label uses, which can include treatment for ADHD, depression fatigue, MS fatigue, cancer related fatigue, cognitive enhancement, and jet lag.
Wow, very interesting. Well, we're gonna take a look at its chemical structure now. Its IUPAC name is a little tricky, but it's 2-diphenylmethylsulfonol, with molecular formula of C15H15NO2S, with a molecular weight of around 273.35 grams per mole. And you can kind of see the chemical structure here on two here, but Abel will talk to us more about the structure in the next slide.
Yeah. So modafinil is a racemic compound, which means it has equal RNS enantiomers. And this is because the sulfur atom of the sulfite group is a chiral center, as you can see below.
Yeah, so just to point out, this is the only sulfur here with this one group here. I'm pretty sure it's a carboxyl group. We have our double bonded oxygen along with this big group on the side, and I'm assuming it has an H, which makes it a chiral center. Now let's take a look at its enantiomers. They only really have the RNS enantiomers, as we kind of learned about in class. With the R enantiomer being armodafinil, um, which promotes longer lasting wakefulness and is marketed as Nuvigile. And this is the one that's mostly in circulation, with around 90% of this R-enantiomer being the one that's actually sold um, for this drug. But similarly, we have the S-modafinil, which is kind of similar, has the same thing, but it's eliminated more quickly, so it's less effective than the R-enantiomer. But it is still used in circulation with around 10% of it. As you can see, this is the R-modafinil enantiomer, and this is the S-modafinil enantiomer.
Yeah, we've already talked about like the benefits of modafinil, but there can also be some side effects. Common side effects include headaches, nausea, diarrhea, trouble sleeping, anxiety, dizziness, back pain, and a runny or stuffy nose. But there are also some severe but less common side effects, which can include skin reactions, heart issues, psychiatric effects, and liver and kidney problems.
Do you think that if I took modafinil, I'd go crazy in Miss Ramos's class?
Um, I'd hope not.
Okay, so let's talk about a brief history of what really happened with modafinil and how it came to be. So it was first discovered in 1974 by Lafon, which is a French company, as a derivative of this certain drug called adrephenol. Um, and it underwent trials and treatments for narcolepsy in 1983. But then the French had a really interesting idea. Um, Maybe we could try this on soldiers. So during 1991, during the Gulf War, um, French military trialed this as a remedy for sleep deprivation for soldiers that were fighting during the time. And France approved this medication in 1992 as uh, Moadial, um, and the FDA followed up in 1998 with a drug that we learned before, which Abel kind of talked about. Um, yeah, and after that, this other company kind of acquired Lafon in 2001, and this is where we kind of really started to see the rise of modafinil with the purified R enantiomer, Nuvigile, which we talked about before, in 2007, really came to rise. And then obviously in the U.S., where we are right now, it became available in 2012.
Okay. There's a lot of interesting facts about modafinil. So, firstly, although it's sold as a 1-to-1 racemic mixture, at a steady state, armodafinil makes up 90% of the circulating drug. This is because S-modafinil is rapidly eliminated. It's eliminated 3 times faster than the ARI enantiomer. Additionally, multiple militaries, as Kyle has talked about before, have investigated modafinil as a fatigue countermeasure for pilots and special forces operating under extreme sleep deprivation. NASA has also studied its use by astronauts on long-duration space missions in order to manage circadian disruption and fatigue. The WADA, which is an organization that oversees the Olympics, banned modafinil in 2004 after athletes tested positive for it, classifying it as a performance-enhancing substance.
Wow.
And lastly, unlike amphetamines, modafinil produces minimal euphoria and little peripheral sympathetic stimulation, which explains how it has a lower abuse potential and also a lower Schedule 4 versus Schedule 2. Yeah.
Well, that's very interesting. Thank you for talking to me about that. Maybe I'll have to hop on modafinil.
No problem, Kyle.
Here are our references, and thank you guys so much.